Hello everyone, welcome to tutorial number 6 for ECE 457A. In this tutorial we're going to mainly discuss some of the games and different types of games you can find in game theory. But before that, let's have a simple discussion, simple slide on Nelder-Mead algorithm for optimization. So here I'm showing you two lines of codes, one for Python, the other one for Matlab. And they both implement the Nelder-Mead algorithm for a function. The objective function that is to be minimized, which is a scalar function. The result is actually the result of that function is scalar, so the function can have multiple variables inside of it. So in Python, we need to go to SciPy library, and from the optimize module, select the minimize function. The inputs are the objective function and an initial guess that is an array of elements, n number of elements. And the method, the type of solver that we want to use is obviously Nelder-Mead. And for Matlab, you only use fmin_search function. The inputs are actually the function to be optimized, and the starting point from which the algorithm attempts to find a local minimum of this function. And we have a set of options that you can use to inspect the optimization process, such as like the number of iterations or plots. So that's for the Nelder-Mead algorithm. Let's move on to game theory. So game theory, as mentioned here, is a theoretical framework designed to conceptualize social scenarios involving rival or opposing participants. So empirical situations may be delineated, like we want to describe the situations that we observe daily and forecast their results, like predict the outcome of those situations using game theory. You have different types of games in game theory. So the first one is cooperative and non-cooperative games. Then we have zero-sum versus non-zero-sum games. After that, we have simultaneous move versus sequential move games, then one-shot versus repeated games, and symmetric versus asymmetric games. So, a cooperative game is a game in which participants can negotiate binding contracts that allow them to plan joint strategies. So we have joint strategies here, which means cooperative. When we do not have that joint strategies, like a game in which negotiation and enforcement of binding contracts are not possible, so that game would be a non-cooperative game. Then we have Nash equilibrium. So a game theory concept that determines the optimal solution in a non-cooperative game is basically the definition of Nash equilibrium. So based on Nash equilibrium, it states that the optimal strategy for a player is to keep their initial strategy, while that player assumes the other players also keep their strategies unchanged. So a game may include multiple Nash equilibria or 0, none. The next type of game is zero sum versus non zero sum game. So, as it is obvious from the name, a game that always produces a net gain of 0, with one party winning and the other party losing, is a zero sum game. But when we have net positive or net loss as the result of the game, that will be a non zero sum game. I'm going to show you some examples for these types of games later on. Then we have simultaneous move and sequential move games. So the other names of simultaneous can be concurrent or static move games. So it's a type of game that involves players engaging in the game simultaneously or concurrently without knowledge of each other's moves or actions. And the players lack substantial information about their opponent's performance and select their strategies independently, irrespective of opponent's choices. So they both act at the same time, uh, and they actually don't have any ideas about strategies of the other opponent. Then we have sequential or dynamic move game. So it's a type of game in which each player moves before others can choose their actions. And the players are aware of the moves made by their opponents and base their decisions on that information for subsequent moves, like chess. So in chess, you basically can see uh, your opponent's moves, and also you can decide your next move based on that observation. Then we have one shot and repeated games. So, one shot games, as it is obvious for the name, a game that is played only once, and a repeated game is a game in which actions are taken and payoffs received over and over again. Lastly, we have symmetric versus asymmetric games. So, in symmetric games, is a game wherein all players are on equal footing, like they have equal position or status, and the same rules apply to all. But in asymmetric game, a game wherein different rules and goals get assigned to every player. Um, so a game can have like two different types. For example, it can be symmetric and cooperative. It can be symmetric and zero sum. Um, and I will show you an example in the next slides. Now let's go through the examples. The first example is for Nash equilibrium. Now imagine a game between Tom and Sam. Both players can choose strategy A to receive $1 or strategy B to lose $1. The scenario when both players choose strategy A and receive a payoff of $1 is a Nash equilibrium. So this is the strategy table. So this strategy when both choose A and you receive $1, this one is called a Nash equilibrium. The next one is the example of zero-sum games. The game is called Matching Pennies. So Matching Pennies is an example of zero-sum games. Two players, A and B, place a penny on the table simultaneously. If both pennies are heads or tails, player A wins and keeps player B's penny. If they do not match, then player B wins and keeps player A's penny. So this is a zero-sum game because one player's gain is the other's loss. So as you can see here, player A's gain is player B's loss. Player B's gain is player A's loss. So this one is called a zero-sum game. When you add them up, the result will be 0. Next up, we have simultaneous move games and sequential move games. Rock, paper, scissors is an example of simultaneous game because both players act at the same time. But for sequential games, we have chess, infinite chess, backgammon, tic-tac-toe, and Go are the examples of sequential games. So you only can move or take an action after your opponent, or your opponent needs to have you first move your pieces, and then he or she can move. Then we have one-shot games and repeated games. So Prisoner's Dilemma that you had in your slides, in the lecture slides, is an example of a one-shot game because a single round of decisions determines the outcome. But if the process was repeated, like iterated Prisoner's Dilemma, now this is a version of repeated game because two suspects face the same dilemma in multiple rounds, making choices over and over again, which kind of doesn't make sense. Okay, we have symmetric games and asymmetric games. So symmetric games, like two-player zero-sum games, are symmetric. So a game can be zero-sum as well as symmetric. So the game has two types. So two-player zero-sum games are symmetric because both players have identical sets of strategies and the payoff matrix is the same for both players, like matching pennies. So matching pennies is a symmetric two-player zero-sum game. Games like Divide the Cake or Cutting the Pizza can be symmetric when both players, actually we have a condition here, when both players have the same preferences and aim to divide a resource fairly. Now the Prisoner's Dilemma can be asymmetric. So we had Prisoner's Dilemma, we had iterated Prisoner's Dilemma, now we have asymmetric Prisoner's Dilemma, which is an asymmetric game where the two suspects may have different stakes or preferences, leading to asymmetry in payoffs. For example, one player faces a much harsher punishment if both players defect. Alright people, that was a short tutorial for today, and until next time.